Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will continue on discussing with more concepts regarding complex number. And the next thing you should know is that whenever you solve a polynomial equation and you get a complex root, the complex roots must always exist in conjugate pairs. Like you have one root as p plus q iota, then it must definitely have another root as p minus q iota, the conjugate pair of that. You can guess that by looking at the structure of the quadratic formula. You know that whenever you get a complex root, that is because you have a root with a negative sign inside it, which turns into iota. So every time you will have an iota coming from here due to a complex root, outside it would always be a plus and minus sign. So that means that your imaginary part of the root should always be with a plus sign and a minus sign, and hence it must always exist in conjugate pairs. So if, like, for instance, you know that there is a particular equation which has a root 2 minus 3 iota, then you must know that it has to have a root which is 2 plus 3 iota. Like, let's say if you have a quadratic equation, it can only have two roots. So that means if one root is 2 minus 3 iota, the other root would be 2 plus 3 iota. But if you have a cubic equation, and let's say the cubic equation has a root which is 3 minus iota, so you know that one other root must be 3 plus iota. And since cubic equation must have three roots, so you know that the other root, the next root, must be real, because since complex roots can only exist in conjugate pairs, so if you have only one root left, that cannot be complex. Now, similarly, if you have, let's say, a quartic equation and you know that one of the roots is 1 minus 2 iota, then you would know that the other root would be 1 plus 2 iota. A quartic equation must have four roots. So that means that the remaining two roots could also be again a pair of two complex roots, or it could be only two real roots, depending on it. But if you know that there's also one more root, which is 2 plus iota, so you would for sure know that the other root must be 2 minus iota. In short, what you have to keep in mind is that every time you solve a polynomial equation and you get yourself roots, and if there is a complex root, or if there are more than one complex roots, then every root should exist in pair. So that means if you have a complex root, then it should have a conjugate pair of that. If you have two different complex roots, so that means there must be four complex roots, because every root must exist in conjugate pairs. Now, how can you use that in situations of solving questions? Like, for instance, I've been told that the root of the equation is 2 plus iota. So if one root is 2 plus iota, I must know that the other root must be 2 minus iota. And if this is the equation, then the roots must satisfy the equation. Here, obviously, it's a redundant or extra piece of information, but somehow you can put 2 plus iota, and once you get the final form, you can equate the real part and imaginary part to 0 to get the values of p and q. But you can do that, the same exact thing, you can do that with 2 minus iota as well, because you know that if one root is 2 plus iota, there must be another root which is 2 minus iota. So if 2 plus iota must satisfy this quadratic equation, then 2 minus iota must also satisfy this quadratic equation. Likewise, if you look at this particular equation and you know that one root is 2 minus iota, the moment you know that one root, which is a complex root, is 2 minus iota, you would know that it has to exist in conjugate pairs. So that means if one root is 2 minus iota, the other root must be 2 plus iota. You can rearrange these equations and get yourself the factors, and you multiply these factors, and after simplifying these, and by the way, when you are simplifying the factors, again, you can ease up the process of simplification by thinking of this as a and this as b, this is again a and this is b. So you can multiply these every time this is going to happen, and you can multiply this by using the formula a square minus b square. So it simplifies very quickly, and once you will simplify this, then you can expand this part as well, and after expanding and simplifying this part, you will get yourself the quadratic quadratic factor. So this is the cubic equation and this is the quadratic factor. So you can find out the third factor by dividing the given polynomial equation with this quadratic factor. So I perform the process of long division, and when I will perform the process of long division, let me just quickly recap how you do the long division as well. So this is your dividend 3z cubed minus 10z square plus 7z plus 10, and this is z square minus 4z plus 5. That's a quadratic factor that you just got. So to get the first term of the quotient, you divide the first term of the dividend by the first term of the divisor. So 3z cubed divided by z square gives you 3z. So that's going to be your first term of the quotient. Once you get the first term of the quotient, then you multiply the entire divisor by this first term. So z square into 3z becomes 3z cubed. Minus 4z times 3z becomes minus 12z square. And plus 5 times 3z becomes 15z. And then you subtract. These two terms will always cancel out. That's why you chose your first term as 3z, and then there's going to be, because you are subtracting, the signs are going to change. So minus 10 plus 12 becomes 2, and 7 minus 15 becomes minus 8. The 10 is being copied as it is because nothing subtracts from it. After getting to this point, you get the next term of the quotient when you divide this by the first term here. So 2z squared divided by z square will give you 2, and if that gives you 2, then you can multiply this entire thing. So z square times 2 becomes 2z square, minus 4z times 2 becomes minus 8z, and plus 5 times 2 becomes 10. And then you do the subtraction. Obviously, we knew that this is one of the factors, so my remainder came out to be 0. But as a quotient, I got myself the third factor, which should represent the real root of the equation. So I got myself this factor and I solve it and I get myself the third root as well. So one root was complex. From that, I automatically got the second root as the conjugate pair. I found out the factor, and once I found out the factor due to these two roots, divided the polynomial to get the other factor, and I was always anticipating the other factor to give me the real root, because imaginary roots always exist in pairs. So if I have two imaginary roots, total 3 roots, so that means the third root has to be real. It's a very similar example. You can again look at it. If I know one of the roots is 1 minus 2 iota, I can easily figure out that the other root must be 1 plus 2 iota. I will get two factors, multiply them, again apply the formula a plus b, a minus b to ease up my simplification, get the quadratic factor, and then divide the polynomial by the quadratic factor. I get myself the third linear factor, and the third linear factor would represent the real root, which is going to be minus 2. So guys, this is how you can find out the remaining roots if you know one of the roots. Even in situations, if you have a quadratic equation, like if you know that one of the roots is iota, then if one root is iota, one factor is going to be z minus iota. And if the other root, you know by default that if one root is iota, the other root must be minus iota, and the other factor would be z plus iota. So you multiply z minus iota with z plus iota, you will get yourself the quadratic factor. After getting that quadratic factor, you will divide this 4th degree polynomial by this quadratic factor. And once you do that, let's see how we get that. If we multiply this, this is going to become z square plus 1 and z4 plus z cube plus z minus 1. So this multiplies by z square. So I get z4 plus z square, and then I subtract it again. So I'm going to get z cube minus c square plus z minus 1. And then I multiply it with z. So I get myself z cube plus z, and this also subtracts, and this cancels, I'm going to be left with minus z square minus 1, and then I'm going to multiply it with minus 1, and that will be minus z square minus 1. So I knew one of the quadratic factors was z square plus 1, and the roots because of that quadratic factor are iota and minus iota. This is a 4th degree equation. I was expecting 4 roots, so the remaining 2 roots are represented by the equation z square plus z minus 1 equals 0. And I can find these roots by applying the quadratic formula, minus b plus minus under root b square. That's going to be 1 minus 4a c divided by 2a. Now it depends. I mean, in this particular situation, I'm getting a root with a plus sign, so that means the remaining roots are going to be real. But if there was an under root with a negative sign, so that means all four roots of the equation would have been unreal. So I can easily simplify this. Let's do the simplification as well. This is going to be minus 1 plus minus 4 plus 1, 5, root 5 divided by 2. So one root is minus 1 minus root 5 upon 2. One root is minus 1 plus root 5 upon 2. And the other roots, one was given to me, which was iota, and the one that I deduced from it, that is going to be minus iota. So these are the four roots of this particular quartic equation. Guys, I hope it was helpful. If it did help, kindly give a thumbs up and share it with your friends, and please subscribe to my channel. Thank you.